So let's look at the next question now. Pratik takes 8 hours to travel 36 kilometers downstream and return to the same spot. The speed of boat in still water is 12 kilometers per hour. Find the speed of the water current. So there are actually four things that you'll have to understand whenever you see a boat problem like this. So see, the first thing that we need to understand is that there is something called the uh, speed of the boat in still water. So this will be still water, and there will be the speed of the boat in still water. For ease, let me call it as b kilometer per hour. So this is the first thing that you need to understand. Second thing, so this b kilometer per hour is the speed of the boat. I'll write it here. Speed of boat is the speed of boat in still water. In still water. So this will be mentioned as b kilometer per hour. So this is the first thing that you need to understand. Second thing that you need to understand is that there is a speed of the stream. So it can be stream, it can be river. Let's see what they have mentioned here. Stream. So let me call the speed of the stream as s kilometer per hour. So s is the speed of stream. Speed of stream is s kilometer per hour. S kilometer per hour. Now, what you need to understand is the meaning of upstream. The meaning of upstream. Usually I represent it like this, upstream. So basically what this implies is that the water is coming down. The river, you are basically facing the river. So what it implies is that your boat is against the river. Your boat is against the river. So water is coming from the opposite side and you are paddling in this side. So this will be the speed of stream. So this will be s, and your speed would be b. Now here what you need to see, this is what is called upstream. Upstream implies you are going against the stream. Against the stream. Now here the very important thing that you need to understand is that in all cases the speed of the boat should be more than the speed of the stream, because if the stream has greater speed and you are not able to manage having a speed more than the stream speed, then you will go back. So always remember that b would always be greater than s, and your net speed would be b minus s. So if you want to take an example, so let us say that the stream is coming at 15 kilometer per hour. So the speed of the boat should be 20 kilometer per hour, and that is why the net speed of the boat would be 5 kilometer per hour. So this is what happens when we are going upstream. Upstream implies you are going against the stream. The river is coming or the stream is coming from the opposite side and you are going from this side. That is what is called upstream. Then there is something which is called downstream. There is something which is called downstream. But downstream implies that the river is flowing in this direction and you are also boating in this direction. So the river or the stream is in this direction and you are also boating in this direction. So in this case, your net speed will increase. You will go at a speed of s plus b because the river will or the stream will add to your speed. So in short, what I'm trying to tell you is, usually I represent upstream like this and downstream like this. because it becomes a bit easier to understand. So when you are going upstream, the speed of the stream would be subtracted, and when you are going downstream, the speed of the stream would be added to the stream to the speed of the boat. So the net would be b minus s, and here it would be b plus s. I hope this is making sense. Oh, in short, what I'm trying to tell you is that when you are going upstream, when you are going upstream, your speed decreases. I'm sorry, your speed decreases, and when you are going downstream, your speed increases. Your speed downstream. Let me call it up. And when you are going downstream, your speed effectively increases. So I hope this is making sense till here. Now let's come to the question again. So Pratik takes 8 hours to travel 36 kilometers downstream and return to the same spot. Speed of the boat in still water is 12 kilometers per hour. Find the speed of the water current. Fine. So now what I'll do is I'll assume that the water current is, let me call this as x. So speed of water current be x, and speed of still water is 12. So this is how the situation is now. So upstream, downstream. So when you are going upstream, because you are facing the water, and the speed of water is speed of water you have assumed to be x. So x would be subtracted from the speed of the boat, which is 12. And in this case, because water would be supporting your motion, so plus x. So this is upstream, this is downstream. See, I'm just referring it as the arrow is going up. That doesn't mean that the water is going up. I just want to represent it as simple as possible. So basically you are facing the water, so that is why your speed of the boat will decrease. That is all that I want to make clear. And another thing that you need to understand is that these are speeds, so this will be in kilometer per hour. Very important to understand this. Let's go back. He takes 8 hours to travel 36 kilometers downstream and return to the same spot. So basically what he does is, he goes 36 kilometers this side. He comes back. So in our representation, we can show it like this. He goes 36 kilometers upstream. This is kilometer. He comes 36 kilometers downstream. When he goes 36 kilometers upstream, his net speed is 12 minus x. 12 minus x kilometer per hour. And here it is 12 plus x kilometer per hour. Now, one formula that you need to understand is that time is equal to distance upon speed. Now, look carefully here. Look carefully here. I'll just erase this because I don't need this anymore. Now, look carefully here. So 36 kilometer he is going at a speed of 12 minus x kilometer per hour. So the time taken upstream, let me call this t1, would be 36 upon 12 minus x. And when he is now flowing with the stream, this t2 would be equal to 36 upon 12 plus x. And as per the question, the total time he takes is 8 hours. So T1 plus T2, is 8. And now all I need to do is I need to put the value of T1 and T2. So 36, 12 minus x plus 36, 12 plus x is equal to 8. Now, see, this is anyways, these kind of questions, the river questions are usually tough. Students face a lot of difficulty when they are solving this, and it takes time when you are doing these questions the first time. And the second problem in these kind of question is that this quadratic equation which becomes, it's a fractional algebraic equation. So this is a bit difficult to solve. There's another question where I had explained the algebraic equations in detail. There was a reciprocal question. This question. You can refer to this question number 4. I have explained how to solve these kind of equations in question number 4. I'll put the link also. You can have a look at that. Because in detail I have gone through how to solve these kind of questions. So I'll be skipping few things. But let's go ahead in how to solve this. So the first thing that you do when you have to solve an equation like this is you take the common factors out. So for example, on both sides you can have 4 as common factors. So I can take 4. See, this algebra that I am doing, this is a bit difficult algebra. So many of the students face difficulty. But I will try to make easy, but it's not. It can't be made easier beyond a point. I hope you understand. So 4 has been taken out, and here you have 8. So this 4 and this 8 will cancel. So I'll have 2. I'll have 2 here. And then what I do is I'll take this 2, 9 common. So I'll have an equation like this. This I can write it as 1 upon 12 minus x plus 1 upon 12 plus x is equal to 2 upon 9. So this is a far easier equation to solve than this, because it has 36, 36, 8. Here you have only 1, 1 and 2 by 9. And then we'll have to solve this to find the value of x. I'll show you the solution, I've done the solution, I'll show you the solution. So this is all that we have discussed till now. So still water is x, Pratik's boat in still water is 8, is 10, and this is the equation we formed. So t1 plus t2 is equal to 8, and then I have taken the 9 out, and I've taken the 9 out. So now the denominator is x plus 10 and 10 minus x. So here I'll write 10 minus x. Here I'll write x plus 10 is equal to 2. I'll request you to refer to that solution of question number 4 again, please. There I have explained this in detail. There also similar algebraic equation is formed. So there I had gone in detail. I'll show you the equation which was formed. See, this is the equation which was formed in question number 4. So please refer to the lecture of question number 4 again. So in the numerator now, this x and x cancels. So I have 9 into 20. This would be 10 plus x into 10 minus x. This is a plus b into a minus b. This will be a square minus b square. So 9 into 20 upon 100 minus x square is equal to 2. And this can be assumed to be 2 upon 1. We do cross multiplication. So this is 9 into 20 is equal to 2 into 100 minus x square. So, and then we can cancel 2 on both sides. So this 2 and this will cancel. So this will be 90 is equal to 100 minus x square, and x square would be equal to 100 minus 90. So x square would be equal to 10 and x is equal to plus minus root 10. So basically the speed, because x can't be negative, so my x is root 10 km per hour, approximately 3.33 km per hour. So this is what the value of water current is. So this is a bit tedious question. I understand that all of us, when we did these river questions, they were a bit difficult to understand. These are the family of problems which are difficult to understand. This a river boat problem, then there is this work problem. The next question is also a bit tough. So these kind of questions are a bit tough. I'll show you some other tough questions. Mm, these water tank and tap problems are also tough. You will have to see these multiple times and maybe try to do more questions, more and more such questions if you want to, master these kind of questions. Uh, you can refer to the playlist I have made. There are a lot of quadratic equations questions there, word problems there. You can refer to that. Basically, it's all about practice. The more you practice, the easier it gets. So let's move to the next question. Question number 8 about Pinto and Issue. Question number 8.